Hello everyone and welcome to the Peel 3D presentation. I'm very happy to be with you today. I'm going to go through what is Peel, the different application we have, and I have a few videos that I'm going to narrate and explain to you. We're going to go through a full project of a reverse engineering part. Welcome to Peel 3D. Little summary of what we do. Let's say you have just 1 minute for me. That's the minute it's important is this slide. So what is Peel in general? Peel is an affordable 3D scanner for many applications. It's a high quality product, has a low cost price tag, it's a proven technology. So people are investing in Peel 3D because they need to measure a part in 3D and they need to bring it into a 3D environment, whether it's 3D printer or a 3D CAD software. So applications are within design, engineering, healthcare, arts, museum are using it as well. A lot of people are using it for teaching purposes as well. The scanners, this technology works hand in hand with the 3D printer and CAD software. Now, how it works, you take the scanner out of the box, you plug it to your laptop, you scan the part that you need, then the results, you can play with the results, get some dimension out, the geometries, and then you send this data to a 3D printer if you want to print it, or to a software, a CAD software like SolidWorks, and you can do a new design or modify the existing design. And it's a great technology. That's it. So that's the 1 minute summary. Now, let's go into the detail. Who am I? My name is Louis-Etienne Bouchard. I'm in mechanical engineering. I started working at Creaform. And by the way, you'll see later on, Creaform is the company that owns the Peel 3 brand. I started as an application engineer, very technical. Then I moved to sales and moved to doing regional management of Latin America. And with the growth of Peel, which is a new brand within Creaform, with the growth of Peel, I was requested if I could join the team because they needed some help. So I was like, yeah, let's do that. Peel is a fun team, so I joined in. Now, Peel within Creaform is the affordable brand of Creaform. We have a dedicated sales team that's about 6-7 people, but at the same time, they're manufactured by Creaform, so we use all this big company for us. And this is my next slide. Now, what is Creaform? So Creaform is a manufacturer of portable and automated 3D measurement solution. So they make scanners, they make probe. So we have solution for 40,000 all the way to 500,000, and Peel is one of their brand for the low-cost section. You have to know Creaform is 16 offices worldwide in 12 different countries, more than 600 employees. Peel is part of Creaform, like I mentioned, and Creaform is part of a bigger family even called Amtech. And Amtech, we're talking about $5 billion in revenue, 16,000 employees. They are in the New York Stock Exchange. So I'm saying this to you because you have to know that even though it's something new, it's backed by something bigger that's backed by something even bigger. So we've got the advantage of being new and being strong at the same time. Now, coming back to Peel, the people that are investing in Peel are the professional and the personal people that wants to have an affordable scanner that's going to give you very good results. So now let's go into scanner itself. The family is divided like this: Peel 1, Peel 2, and Peel 2S. Then on the price range section, you've got the Peel 2 CAD and the Peel 2 CAD S, and at the end, you've got the bundle. So the Peel 2 and the Peel 2 CAD is pretty much the same scanner. The Peel 2 CAD would differentiate it. It has more function to it. The software has more reverse engineering function or design function, if I may say. It's the same for the Peel 2S and the Peel 2 CAD S. It's the same scanner, but then the Peel 2 CAD S has more software capabilities. The bundle at the end is the Peel 2 CAD and the Peel 2 CAD S together. So it's like it is buying the two of them and getting the second scanner, for half price. So that's quite an aggressive offer actually on the market. Now let's go and check why we have each of those scanners. We cover a wide variety of different applications, and each scanner is better in a few of them. So the Peel 1 is being used a lot for scanning human body parts, hands, feet, faces, torso. We use it in clinics around the world. We've got a partnership with those 6 companies that you see there. Those companies have their own software, and they rebrand our scanner with their own software. So this is one of a common use for the PL1. Can be used as well in this industrial application. The PL1 do not capture color. That's the PL2 and the PL2S. So that's the next thing on the portfolio. So now moving to the PL2, you see an example at the bottom here, someone that wanted to scan feet in color, so he used the PL2 scanner. Lots of people that are using it is for larger parts, something that's 0.5 meter all the way to 4 or 5 meter in size. You can get details up to roughly 1 millimeter, so you have something that's the size of 1 millimeter. That's how details you can go. It scans with color, as I mentioned. You can scan inside, you can scan outside as well. You see some examples. So for architecture, arts, it's a very good product for that. PL2 and PL2 CAD are very, very popular for custom design. So aftermarket parts, we've got people making custom delivery van as well. People that are going to say, I have furniture and I'm going to be adapting something to it. So this is very popular for that market. Those are other examples. You can see larger part here. You can see the extent of what the scanner can do. Other people, for example, Shape 3D company that makes surfboard manufacturing software using our scanner as well. So you have to think about anything you can play with in a 3D environment. So that was the PL2. Now the PL2S, it's the same. It's the same type of scanner than the PL2, but the PL2S is for smaller parts of the device. S. So we're using it for parts from 5 centimeter to about 0.5 meter in size. The PL2S and the PL2 S will get smaller details, so below 1 millimeter, and that's so if you were saying most of the parts that I'm going to be scanning are under 0.5 meter, then the PL2S and the PL2 S is the best choice for you. Now, if you want to do both, then it's the bundled. The PL2 it's the white one at the bottom, has a wide section of scanning, wide field of view, whereas the PL2S has a much smaller field of view. That's why one of them has a better resolution than the other one. That's how they differentiate each other. Now, in your process, the way that we work is that the scanner will output an STL file, which is thousands and thousands of small meshed together. In your working, you will have, with the basic PL software, you will have some tools to help you out cleaning up, maybe going for a 3D printing part. But if you want to go into a CAD environment, that's why people are using the PL2 CAD or the PL2 CAD S. So you can see you're going to be able to do more of the workflow process leading all the way to a 3D CAD model. Those are the functions that are included with the basic software. So you can see it's a lot of tools. You can fill the holes. You can do remeshing if you want. You can do a water tightening. You can clean mesh. The clean mesh is a tool that will check all the holes and everything you have. So you can see at the bottom everything, all the different activities and action you can do, and this is included. So that's one advantage of our technology. Those tools, you don't have to pay extra money. They are included with the basic scanner. Now, why are people investing more into the PL2 CAD or PL2 CAD S? It's because they want to do reverse engineering. So that's why we have the creation of entities here, planes, cylinders, circles, slots, cross section. If you want to get like the silhouette of the part, we've got more tools for freeform surfaces. One example is let's say I'm scanning my hand. I cannot define my hand with cylinder planes and things like that. I will need the manual surface or the auto surface to create something that goes around my hand and covers everything. So there is a video available on YouTube where actually scanning my hand and going into SolidWorks. So those are the different application and the reason why people are investing into a Peel-to-CAD S. This is an idea of the workflow. So I'm scanning the part, I'm getting my 3D geometry, going to the Peel-to-CAD software to get all the cylinders and planes and everything I need. Then I'm sending all this information to my 3D CAD model, where I'm going to use that to finish the 3D model, and then I have the 3D model in it. Now, what makes this better than I wish I could say that, you know, there's a spec here that we beat. There is, I mean, there's never any specification, but at the end you might find that other companies are able to scan as well. We usually scan much faster than them. You're going to see this in the video later on. But what's very important is first the quality of the product. If you're investing into a Peel, you know it's been manufactured by Creeform on the same production line as the metrology grade and $500,000 product. Creeform has an ISO 17025 certification for some of the products, so it's a rigorous manufacturing. The other thing is, if you ever want to test the precision, the accuracy, the repeatability, no problem. You'll see how we are within, you know, the spec that we say. And the people are also investing with Peel because of the overall solution. Because not only the scanner, all software and everything that's included, the support, the tools that they get that are available, the community as well that are using a Peel 3D scanner around the world. If you are in the educational sector, I wanted to let you know that we have a solution from a Creeform side. So it's the same scanner as Peel, it's just branded with the Academia name. So Academia 10, 50, 20. So we have a special package with tools, teaching material. We have some licenses to equip, for example, a classroom. So we have network licenses. And the prices are the same depending on the product. It's just that the software offer is different to be adapted to university and colleges. So feel free to ask about the Academia product. They're very good and very popular too. Now, being a Peel user is also being part of the Peel family around the world. So you don't have to believe what I'm telling you today. I hope you do. But if you have any doubts, you know, just go online, go on our Instagram page, see what our clients are posting and what we're sharing. Check what's available on the web. You'll see stories, you'll see comments about what people are doing with it. And we really hope that you'll want to join the family and start posting and sharing what you're doing with your Peel 3D scanner. So now I'm pretty sure you're looking forward to see what the scanner can do. So the video I have here, well, it's a bunch of videos that I put together. So this example, the first thing I'm doing is I'm skateboarding at the office, and I use my skateboard to be able to scan and showing you the complete reverse engineering, and I'm going to be using SolidWorks at the end. So this is to show you how simple it is. You get the scanner out of the box. You've got a wire to plug your electricity. You've got USB cable that you plug into your laptop. You plug the scanner. You just double click on the software to start it up. Sometimes if you haven't used the scanner for a long time, you can do a calibration. It takes about 30 seconds. So I didn't do it in the video because I had used the scanner previously during the day and I had calibrated it in the morning. So there's no editing. As you can see, I really want to show the whole process. So I'm plugging the scanner, starting the software, and then I'm clicking scan and I'm going. So now the way the scanner works, it projects a pattern of light similar to a QR code, you know, black and white, onto the surface. Then the cameras are taking picture of how that pattern sits onto the surface. And then from that, they create the geometry. The scanner aligns himself because you can see I'm holding the scanner in my hand. So obviously I need somewhat of a way to have the two of them aligning. So the scanner uses the geometry of the part. So you see in yellow, that's what it's seeing at this precise moment. So it's using the geometry of the part to align the data before and after. But it's all using the target that I have put on turntable. So you can see a rotative table that I use to rotate the part. It's easier than me going around the table. But you can see on it, I have put some stickers. Here, a 3mm circle high reflective sticker. So the scanner is able to use them as well as a reference. Because if I'm scanning something that's flat or something that does not have a lot of geometry, then the scanner will be able to rely on those small little stickers to position himself and be able to work with that. So I finished scanning the first side of the part. I'm going to do both. As you can see, I'm done scanning. I click on stop scan, I wait a few seconds, and I have an STL file right away. So this is not a point cloud that I have to remesh. I don't have to reprocess what you're seeing right now. This is the end result right away. Well, after 15 seconds, let's say, of waiting time. So now what I'm going to do is in the software, I'm creating a new scan, and I'm going to flip the part over and go and scan underneath. And afterwards, as you can imagine, I'm going to merge the two of them together. So now I just want to make sure that the part won't fall on the sides as I'm rotating the table. So it's not, I'm good to go, I can scan. There is no limit, by the way, how many sides or how many scans. If it's a complex part and you want to mount it in different sections, there's no limit to how many scans you want to make and merge them after. What I'm doing right now with the scanner is I want to make sure that I'm grabbing the sides so I have surface on each for each scan that are connecting them together, that are similar. And the way that you want to scan as well, because you have a handheld scanner, and that's the big advantage of a handheld scanner, is you can really go and move the way you want and grab the data that you need. I'm going to be focusing on, I have small holes here, so I want to make sure that I'm scanning not like this, but I'm scanning with an angle, so I've got the data inside the hole and everywhere. So what I'm doing as I'm scanning is I'm looking at the screen and I'm making sure I'm grabbing all the data that I need. Sometimes a little more because it's not so long to do. So next step after that is going to be cleaning all the data that I have acquired. Because obviously you can see I'm scanning and I'm picking up the table. There is some tools where I could use a clip and plane, so I would not capture the tools. There are different things that you can use later on in the software. So now I'm done scanning the second side of the part. Software takes a few seconds to load. And by the way, this depends on the laptop. So we always put the minimum requirement, but we always tell people, the better the laptop, the faster the whole processing will be for the scanner. So now I've got my two parts. This time the video is running a little faster because I wanted to show all the post-treatment, but I think it was taking too much time. So now I'm removing the data that I don't need, the table, the extra parts that I have around. I'm doing that for both sides of the scan. So sometimes you have areas where the scanner didn't see quite well, so this might not be the best data. This is something you can erase as well. It doesn't take much time. But once you have now, I'm going to have my two clean section, the one that I clean, and I'm going to merge together. What's interesting is I'm not merging the STL at the end. I'm really merging the data from the scanner. So I'm really getting a very accurate merge of them. So the way the software works is I'm telling, this point is this point on this part, and this is this. Then it does a best fit. And now it's merging all the data from the two of them together. So I only have one part. There you go. That's my 360 all around part. Now I'm jumping into the Peel to CAD or the Peel to CAD S module. So now I'm creating the geometries that I need to go create a 3D design later on. Right now, you see I created a symmetry plane. So this is one tool we have. When you create a plane, you can ask for the symmetry plane. You can just draw a line to help the software know where it's at roughly. And then it creates a symmetry line. Now I'm creating my cylinders that I will need later on. I've created the holes, the planes. You basically go around and you click on the software what you want to create and where. And that's all the data that you will need later on. I'm creating a little more than I need, but that's helping along the process. Very important tool, cross section. So now I'm using the planes to do cross section, so I get contour line that I'm going to be able to use to create a sketch later on in my 3D CAD software and create like extrusion. So those cross section are very important. So now I've created everything I need. I save my mesh as an STL. By the way, the STL file is the same file that I use a 3D printer. In that case, I'm using SolidWorks, so I go in there. So I import the STL at first. That's the first thing. Well, I open the STL that comes into SolidWorks. By the way, it's a similar process depending on the software. It's just the button that changed, but this is the way it works. You can see here very nicely the STL, all the little triangles that represent the surface. Then I go and insert feature, and then I go to import, and I can import all the entities that I created. Voila, that's where they all are. So my first stop will be creating the 3D model of the part. So now I'm going to use the plane that I created, the symmetry plane in the middle, and I'm going to use a cross section that I have to be able to draw. So you can see it's orange right now, so that means that when I'm drawing, it's picking up directly on the 2D cross section. So that's very useful, because what you're doing right now is you're redrawing the part, but you have the drawing behind, you have the dimension, everything is there. So now it's depending on the person, it's your decision if you're going to make a perfect copy with all the errors and misfit that might be on the part, or if you want to create a perfect part. So when I ask the software what's the distance here, what's the angle, the software tells me the angle is 44.9, but it's me that decided if I want to keep it 44.9, if I want to go 45, so that's a bit what I'm doing right now. I'm changing, and in that case I realized that 45 was not the angle. I realized actually no, this is 47 degrees, and I can see how the line would fit nicely on this. So that's the way we work with that. You basically redraw or reorganize the drawing that you have to be able to create, and at the end you're going to have a complete 3D model. I'm trying to see if I have some special tricks to tell you. Not much. I'm not pro on SolidWorks. I learned it just to be able so people see how it works. So, that's interesting. It's 133.99. So I'm like, no, this is probably meant to be 135 degrees, which is 45 degrees in the other area. So now that I'm done, I'm doing that sketch. For sure, you can guess I have another sketch to make, and then I'm cutting the two sketches together with extrusion and Boolean functions, so that at the end I have the geometry that I need, the core geometry, I should say, that I need for this design. Next step for me, it's going to be creating the holes that I have around it. So I created the cylinder when I was in the PL2CAD software. So I use the cylinder and the plane to create a circle. So now I have a clear circle. So it's easy to go sketch, click on the surface, and just draw a circle. And then once you've done it, you can check the dimension and you can compare what was the dimension, the intention when designing the part. So again, then it's your decision if you're gonna copy what's been made already, or if you're gonna create like a perfect part. In that case, where you're gonna put perfect dimension to it. So you see a click, and then I just draw, and I can control the geometry, and I realize, wow, this is no way this is 8.92, or it has to be 9 the dimension. So the rest is regular SolidWorks process of creating holes and Booleans operation and design intent. By the way, if I had a surface that was freeform, it is possible to have like a one surface freeform area. If you're scanning like the top of a mouse that's curved in the side as well, it's doable to create several surfaces and peel to CAD to export it to SolidWorks. In that case, the part was not didn't have any freeform surface, so I didn't have to do it. So what's interesting now is I'm doing the chamfer, I'm doing the fillet, things like that, but I always have my dimension, I always have my STL underneath, so I can always check what I'm rebuilding if it's good or bad. So this is what's interesting about using a PL3D and using CAD software, is when you're doing a design, you kind of already have a helper or someone that tells you if you're doing it good or not. So that's a big time saver, especially not only when you're doing a reverse engineering, but when you're doing a custom design. You go on site, you scan, you really take all the information you need. Now I'm showing different example of parts that we can scan. So just so you know that it's not like limited to white parts or black parts, it's really different. So now I'm showing you a project we did. This video, by the way, is available as well on YouTube. So this is a project with the PL2 CAD because it's a wider part. It's about 4 to 5 meters. I don't need I don't need details below 1 millimeter. I need to know where the brackets are. I need to know the shape of the exhaust, the pipes. Then, in the software, what I'm doing right now is cleaning them up, and then I'm using the PL2CAD tools to fit cylinder mostly in that case. So I have my tools that I'm going to export into my CAD software. And this example here is from Mustang as well. What we're doing in that case, it's not really reverse engineering. What I'm doing is I'm scanning the parts, so I have the geometry to create a custom design. In that case, what I needed was the geometry of the hood. So now I'm using the manual surface to create like a grid, to create a surface that will allow me to capture the hood and go in SolidWorks and design something that would fit perfectly on the hood. In that case, it was a custom air intake. So now I have my surface, I'm going in SolidWorks, you can see the end results. So you can see how the shape really follows the hood. So that was an example I did recently. I wanted to show you this as well. So this is the PL2 with color. So I just enable the color, and you can see how it works on a human body part. So it's really just like the PL2S that we saw. You really want to go on the part. You can see there's no targets on the legs. I put a few targets on the floor. But there's no target on the leg as the scanner has enough geometry. So that sums it up for the video. Again, some slide that we use at the beginning. So what is PL3D, as I mentioned? I hope I was enjoyable for you. I try to go around and explain the best I could. If you have any question, feel free to send question to me. Feel free to contact your local distributor as well. That's not a problem. Check as well on YouTube, Instagram, on the web. We're always there to help us or the whole PL3D family. So thanks again, and have a good day.